All right, section 6.1 deals with exponential functions, and today we're going to look at the key features and graph some of them. So an exponential function is going to be any function in the form where we have y equals a times b to the x power, where a and b are constants that can't be zero. And really the key here is that x needs to be the exponent. So if x is the exponent, then we are going to be dealing with an exponential function. So the first thing we're going to do here is graph them, and this year we're just going to use calculators to do this. So our first function is f of x equals to the x power. Again, since that is an exponent, or our exponent is x, that tells me that, hey, we have an exponential function going on here. So to use the graphing calculator to graph it, turn it on, we're going to go to y equals, and we're going to type this function in. So we are going 2 to the x power. From there, we can get our table of values by hitting second table. And then now we can figure out, okay, like what our values are. So we can see when x is -2, we're going to have a y value of 0.25. When it's -1, we're going to have a y value of 0.5. 0 goes with 1. 1 goes with 2, and 2 is going to go with 4. So I'm going to go ahead and plot those points on my graph. It's going to end up having like a little curve going on. So we're going to have a graph that looks like this. You could also get a rough idea what the graph looks like by going back to your graphing calculator and hitting graph. It'll give you a rough shape. So there we have it. Domain, I look at that, I want to see what are my possible x values. It goes to the left for forever and the right for forever. So that gives me a domain of all real numbers. Range, we're going to have every y value greater than 0. Okay, so I get close to touching 0, but I don't. We just go up for forever from there. Since I get close to 0 but don't touch it, that tells me I have a y, or a horizontal asymptote of y equals 0, which we can actually go ahead and draw in using a dotted line. And then the last things we want are the y-intercept and then the end behavior. Y-intercept is whatever my y value is when x is 0. So in this case, we're going to have a y-intercept at 0, 1. And then end behavior asks me what the graph is doing as I go to the left and as I go to the right. So as I go to the left, my graph is approaching 0. Okay, it's approaching it but not touching it. And then as I go to the right, it's going up for forever. So we are going to positive infinity. So that would be a basic exponential function right there. B, we're going to do the same deal. Again, calculator time. So if I go on a calculator, we're going to go y equals. Type it in exactly how it looks. So 5 parentheses 1/2. Close the parenthesis, raise it to the x power. From there, okay, so there's my equation plugged in. From there, you're going to go second table, and then we can start filling stuff in. So when x is -2, y is going to be 20. -1 goes with 10. 0 goes with 5. 1 goes with 2.5, and 2 is going to be 1.25. Go ahead and plot the points. -220 doesn't fit on there, so I'm going to go -110. I'm going to have 0, 5. We got 1, 2.5, and then 2, 1.25. Double check what the graph is supposed to look like by hitting graph, and then there's my curve. Okay, so we pass through the points, and again, we are approaching 0, but not touching. So domain, it goes to the left for forever. That's all real numbers. Range, it's every y value above 0, so y greater than 0. Horizontal asymptote, again, we're approaching 0 but not touching, so it's y equals 0. Y-intercept, what's my y value when x is 0? It's going to be 5. And then end behavior. As we go to the left, my graph is going up for forever, so it's going up to infinity. And as I go to the right, it's going down, approaching 0. Okay, so that's example 1, just the basic graphs for exponential functions. Example 2, we start talking about shifts. that are going on. So for these shifts, you have your translations left, right, up, down. We could also have reflections or stretches. It's going to follow the same exact rules that we've been using all year. So out front, if you have a negative sign, it's going to tell us that we are reflecting over the x-axis. And actually, let's go ahead and write our general form. So our general form is going to be f of x equals a bx minus h plus k. All right, so if a is negative out front, that's going to tell me that we have a reflection over the x-axis. The numbers touching x, so left, right, would be up here, and it's opposite of what you think. And then the plus k on the end is up, down, and you just do what it says. So for a, I got a negative sign out front. That tells me that we need to reflect over the x-axis. And then I have nothing else going on there. So that's the only transformation we have going on. From there, you could actually just plug this in the calculator and get your points. So again, y equals negative 3 to the x. I go to my table. And we are going to get, I'm just going to pick 3 of them. So I have negative 1, negative 1/3, 0, negative 1, and then 1, negative 3. And again, I pulled those all from the calculator. You're going to have a smooth curve. And then we're going to answer questions. So domain, again, all reals. This time, my range is every value below 0. So it's y less than 0. Horizontal asymptote is y equals 0. Intercept is 0, negative 1. And then end behavior. As I go to the left, we are approaching 0. And then as I go to the right, we are going down for forever. So we are going to negative infinity. B. Look at B. I want to know what transformations are going on here. Really, the only thing we have going on is the minus 4 on the end, so that tells me to go down 4. Go ahead, type it in. So I got y equals 3 to the x, and then we are going minus 4 on the outside. Go ahead, table. 3 points again, so I got a point at 0, negative 3. I got 1, negative 1, and then we are going to have 2, 5. So we're going to have a curve coming up like that. Again, answering the questions, you got domain, all reals. Range is y greater than negative 4 on this one. Horizontal is y equals negative 4. Y-intercept. Y value when x is 0 is 0, negative 3. And then end behavior, as I go to the left, we're approaching negative 4. As I go to the right, we are going to infinity.